You ever look at an app on your phone or some piece of software and just wonder, how does that actually work? It can feel like total magic. But today, we're going to pull back that curtain. We're going to show you this simple, secret recipe that's behind, well, pretty much everything. All right, so to kick things off, I've got a kind of weird question for you. Why on earth is a programming language from the 1970s? I mean, that's like ancient in tech years. Why is it still such a huge deal? In a world with all these new, flashy languages popping up, why should any of us care about this old-timer? Well, the answer is actually really simple, but it's super powerful. See, C isn't just another programming language. Nope. It's more like a master key, a key that unlocks the door to understanding all programming. Seriously, once you get C, you start to see how everything else works. So let's really dig into that. Why do we call it the master key? Well, it really boils down to a few core things that make this language so foundational. Okay, first off, think of C as the grandparent of a lot of modern languages. It's kind of the original blueprint that so many others copied. Then there's its speed. C is a sprinter. It's built to be incredibly fast and efficient, which is why it's still used for really high-performance stuff. It's also a bit of a strict teacher. It doesn't hold your hand. It forces you to learn how a computer really works, which builds some serious discipline. And finally, it's just everywhere. We're not just talking about your computer. It's in your car, your microwave, all sorts of devices. And you can literally see that grandparent idea right here in this timeline. Look at this. It's like a family tree for code. C is born in the 70s. Then, in the 80s, you get C++, which builds right on top of it. Then comes Java in the 90s, and guess what? It's heavily influenced by C and C++. And even today, languages like Python, which feel way simpler to use, are actually standing on the shoulders of C. It's kind of like learning Latin. Once you know it, all the other Romance languages just click. They make so much more sense. So because C forces you to get down to the basics, it helps us see how computers actually, well, think. And the biggest, most important secret of all comes down to a super simple three-step pattern. It's called the IPO model. And this is the real secret recipe we were talking about. It's the fundamental flow of basically all software. Okay, so here's the absolute key. Almost everything any computer does can be broken down into just these three steps. Step 1, input. That's just data coming into the system. Could be you typing on your keyboard, clicking your mouse, or even a sensor picking up the temperature. Then, step 2, process. This is the thinking part. The computer takes that input and does something with it. Calculates, sorts, whatever it needs to do. And finally, step 3, output. That's the result. Something pops up on your screen, you hear a sound, a motor spins, anything. So just remember that. Input, process, output. That's the core loop of everything. All right, now that you know the pattern, you're going to start seeing it everywhere. Let's look at how this super simple model is hiding in plain sight, even in the most complex apps that we use every day. Okay, let's start with something really simple, a calculator. The input, well, that's easy, right? It's the numbers and the symbols you punch in, like 2 plus 2. The process? That's the calculator doing the actual math. And the output, the number 4 that shows up on the screen. See? Input, process, output. Super straightforward. Okay, but what about something way more complex, like Google Translate? Let's check. The input is the phrase or the sentence you type in or even speak into your mic. Now the process, this is where the magic really happens, right? The system analyzes all the words, the grammar, the context. And the output? The translated text or speech that comes out the other side. It's pretty amazing, but even for something that sophisticated, that same fundamental pattern is right there. All right, so input and output are pretty clear, but let's zoom in on that middle step, the process part. What's actually going on inside that black box? What are the ingredients that make all that thinking happen? It turns out the process step isn't just one magical thing. It's actually made of two key components that work together, something called data structures and something called algorithms. And these two things, they're the absolute core building blocks of all software development. Here's the best way to think about it, and it's a great analogy. Data structures are basically the containers. They're how you organize and hold on to the input data. Think of them as different kinds of boxes or filing cabinets. An algorithm, on the other hand, is the recipe. It's the step-by-step set of instructions that tells the computer exactly what to do with the data that's in those containers. You need both. You need a container for your ingredients, and you need a recipe to tell you how to cook them. Okay, so we've got our big idea, the IPO model. And we know the process part uses data structures, the containers, and algorithms, the recipes. So let's put it all together now and see how it works with a classic example, figuring out if a year is a leap year. Check out how perfectly this fits. The input is just a single year, right? Let's say 2026. The data structure, our container, is just a simple integer variable, a little box to hold that number. The process is running our specific recipe for this problem, the leap year algorithm, and the output is super simple, just a yes or a no. And here's the recipe itself, the algorithm. It's just a set of very specific rules. A year is a leap year if, 1, it's divisible by 4, unless it's also divisible by 100. Or, rule 2, it's just divisible by 400. That's it. That simple step-by-step logic is the entire heart of the process for this problem. And that really is the whole secret right there. You take your data, you put it in the right container, which is your data structure, then you apply the right recipe, your algorithm, and that combination is what creates the magic. That's what transforms a simple input into a meaningful output. So when you boil it all down, it comes back to this one number, 3. Just 3 simple steps. Input, process, output. That's the pattern that powers almost all technology, from the simplest calculator all the way up to complex AI. And I'm telling you, once you see this pattern, you can't unsee it. It's everywhere. So I'm going to leave you with a little challenge. Now that you know the secret recipe, start looking for it. Look at the technology all around you. Your smart speaker, Netflix, the GPS in your car. Ask yourself, what's the input, what's the process, and what's the output? I promise, once you start looking for it, you'll realize it's absolutely everywhere.